Okay, so they give us a triangle or information about a triangle. If they just give you the information, I strongly suggest that you actually draw the triangle. So they told us that of this triangle, side A, and I know that's side A because it's a small letter, because notice all of the capital letters are the corners. They're always our angle measurements. And then the little letters are the small letters, and they're always opposite of the same letter. Like if this is capital A, then this has to be little a. If this is capital C, then this has to be little c, directly across from it. And then capital B, and over here is little b. So it really didn't matter if you drew this and you put A over here and then B and then C. That's totally fine. Name your corners, but then make sure the opposite side has the same letter, just in the lower case. So I labeled mine, and I put for little a, I put 6.9. For angle A, that was my 47 degrees. And for angle B, because these are capital letters, that's how I knew they were angles, angle B was 69 degrees. So the first thing they asked me was find angle C. And what we have to keep in mind is that every triangle in the universe has 3 angles, and those angles must always equal 180 degrees. So to find this third angle, these 3 need to add up to 180. So you're going to add these 2 together and subtract it from 180. That will give you this answer. So we're going to add the ones that we know, and then we're going to subtract from 180 to find C. So that's how I found out that C is 64. So now I know the 3 angles. Now the next thing they wanted me to do was to find the side B. Well, you need to ask yourself a question whenever they want you to do this. You need to ask, do you know a set of big A and little a, or big B and little b, or big C and little c? Do you know a set where you know both values of the same letter? And if you do, then you can use the law of sine. Actually, they put an ES. It's on your formula sheet at the top on the back side, the law of sines. So here, what it means is that if you have a set, you can put it into a fraction form. You can put the angle with the sine notation here, and then the measurement of the side down here. And when you make this, it has to mathematically be equal to one of the other sides angles set up the same way. So each of these is equal to each other, and we can use this idea to find a missing side or find a missing angle. So when I come over here and I look at this, I have a set. The only set I know for sure where I know both the side and the angle is I know angle A and I know side A. That's a set. So I can use this information to find the measurement of little b. And so what I'm going to do, so we know big A and little a, and so it tells us find side C. Oh, I'm sorry. Yeah, they're having us find side C first. I apologize. Okay, so I'm going to put the information for A's here, big A, little a. So I'm going to do sine of 47, because that's the angle of A, over the measurement of little a, 6.9. Then for angle C, to find little c, angle C was 64, so I'm going to do sine of 64 over a blank spot, because we don't know what side C is. And this is what we call a proportion. When it's set up like this, where it's a fraction equal to a fraction. We used this in previous sections when we were solving percentages with like is over of equals percent over 100, that kind of thing. Anytime you set something up as a fraction equal to a fraction, you can find any of the missing numbers by a method where we cross multiply where we can, and then we divide by the number we haven't used. Like here we can't cross multiply because there's no number down here, okay? But we can cross multiply this way. So we cross multiply and then we divide, Okay, and when we're doing this, be sure and close any parentheses on the sine stuff. So we're going to cross multiply. We're going to say 6.9 times sine of 64. And you put that in your calculator. 6.9 times, use that sine button, and then 64. And you'll notice on your calculator that that starts you with this first parenthesis, and then you type in 64. Now it's going to be important that you close this parenthesis right here. If you forget to do that, it's going to give you the wrong answer when we're doing this. So we should have 6.9 times sine of 64 with their parenthesis closed. So we cross multiplied here and divide by the number you didn't use. So we'll divide by sine of 47. Again, close your parenthesis here, just get in the habit of doing that. So when we did this, we have 8.479725891. But it said round it to the nearest tenths place, so I underlined the tenths place and point to the number next door to make my decision on what to do. And so the 4 needs to round up to 5. So the measurement of side C is 8.5. So we now know this is 8.5 here. Now they want us to find B, and it doesn't matter which set we use. We can, because we know 2 sets now. We can either use set A and A, or we can use set C and C. Both of them will create the same answer when we're solving for B. So I decided to just stick with the one I used up here, sine of 47 over 6.9. And then I put angle B, which was sine of 69, over blank. And again, cross multiply where we can. So it's 6.9 times sine of 69, closing that second parenthesis, be sure and do that, divided by sine of 47. And let me pull up my scientific calculator. I closed it out. Let's see what happened to it here. Hang on. Okay. Let's see what that answer is. Clear this out. So 6.9 times sine of 69. Close that second parenthesis. Divided by sine of 47. Close that parenthesis. All right, this one comes out to 8.807920065. So the tenths place, that would make this 8.8. Now, somebody, as I finish this up, one of the things that people have been asking me a lot is, how do you know when to use sine, and how do you know when to use inverse sine, which is that right above that sine key on your calculator. Inverse sine looks like this, sine with a -1. And I will tell you, the only time we need to use inverse sine, inverse cosine, inverse tan, inverse is when we're trying to find the degrees of an angle. Notice we were finding the sides, and so we just used normal sine. But if we were somehow needing to use that to find an angle, and we'll do that on another example in a little bit, if we're doing that to find an angle, then yes, we need to use inverse sine or inverse cosine, depending on which thing we're using.